Okay, this is the Unit 4 Algebra 2 Honors Review Guide. Gonna start with just like an overview of what we cover your section. So 4.1 was all about exponential functions. And important to remember is the parent function. So we have f of x equals a times b to the x, where a is that initial value and b is the growth factor. Okay. And remembering that if b is greater than 1, we are going to increase, right? And then if b is less than 1 but greater than 0, we are going to have decay. Okay. Also in this section, we graphed functions, so like understanding where is the HA, right? You know how to find the horizontal asymptote, and you want to look for the vertical shift for vertical shift. And yeah, that's pretty much 4.1. 4.1b and 4.2 was about compound interest. So we have these two formulas. We have A of t equals p 1 plus r over n to the nt. And this is when we're compounding, quarterly, monthly, daily, etc. And then we have p e to the rt. And this is for continuous compounding. Okay? So make sure you know when to use each one. This is continuous. This is compounded discretely. So, after months, days, etc. Okay. That is 2. On to 4.3. 4.3 we had introed logs. This is all about logs. And you learned how to read them. So learning that log base a of x equals y is the same as a to the y equals x. Okay, so really understanding how to read them, how to convert them, really important. And some basic log properties. We have log of 1 is always 0. We have log base a of a is always 1. Log base a to the n is n. And then a to the log a of x is x. Okay? So make sure you know and understand those 4 properties. Okay? We also graphed logs. Yeah, so similar to 4.1, like understand, know how to sketch logs. And like you were looking for the vertical. Where is the vertical asymptote? We're going to do one of those problems in a moment. So we've got to practice with that. Then we have 4.4. These are the laws of logs. So this is about condensing and expanding logarithms. We have the 3 laws. So we have log AB equals log A plus log B. We have log A over B equals log A minus log B. And then we have log A to the C is the same as C log A. Okay? Important here is that the bases must be the same with these two rules, right? This only works if, let's just make all these A. Okay. All right, so then you apply those to expanding and condensing. We also have the change of base formula. Change of base formula is I'll put it right over here. Log B of A is equal to log base x of A divided by log x of B. Okay. All right. Then we had 4.5. This was solving functions. So solving exponential, and then we have solving logs. So two different kinds of problems. Solving exponential, you had two methods. You either make bases same, which we'll do a practice problem later, or you isolate exponential and take log. For logs, similar, it's either one, set log both side, or two, rewrite isolate log and rewrite as exponential. So they're kind of they're very similar, the two methods. It's either you're making the bases the same, making the logs the same both sides, or you're isolating the exponential or isolating the log and then you rewrite it as the other version. Okay? That is solving equations, and we'll do some of that in the packet. Then we have 4.6. So 4.6 is the modeling or the applications. And for here you have the half-life, double time, and cooling. You want to know how to apply the formulas, but don't need to memorize. The only formulas to memorize are going to be the change of base, the properties, so 3 log laws, and the 2 compound interest ones, these 2 here. Okay, so those 2, the log properties, change of base, are the ones you need to memorize. You'll be given the formulas here, but you need to know how to apply it. And you need to understand what the different parts mean. Okay. So for example, I'll show you one of them. N of t equals n naught 2 to the t over a. I'll give you this part, but you have to know, oh, this is the starting value. We're doubling. This is the amount of time. This is the time to double. You have to understand that. Okay. And then you have to understand how to convert it to the other form, n naught e to the rt. Okay. All right. Let's do some problems. Graph the function and analyze the following. Log base 2 x minus 2 plus 3. Following 2 points in the table. So 2 points you want to go for are, you want to set the inside equal to either 1 or the base. So let's set it equal to 1. So to set it equal to 1, we're going to make it 3. When I plug in a 3, log of 1 is 0. So 3 is just 3. Okay. Then I'm going to set it equal to the base. So 4 would make it equal to the base. Log base 2 of 2 is 1. Negative 1 plus 3 is 2. So let's go ahead. Let me make my little axis here. I'm going to plot those 2 points. So we're going to have 3, 3, 1, 2, 3, 1, 2, 3, and then 4, 2, 1, 2, 3, 4, 1, 2. Okay? And then we are going to look for our vertical asymptote. I'm going to jump to that right now. The asymptote. So the asymptote happens when the log is 0. So how do we make the log 0? Well, x equals 2. X equals 2 is going to make the log 0, which means that I can go ahead and sketch that here too. Okay, and then from there, I can get some idea of what this will look like. Okay, what are the transformations? Oh, this is a typo. This should not be ln right here. This should say log 2. That's a typo. So what do we got? We reflect over x-axis. Then, so this would be number 1. Then 2 shift to right, and then 3 shift 3 up. The order does matter here because if you reflect after you shifted up, it's not. It would be a -3. So you want to reflect. I'm addressing that reflection first, then I'm moving to the right, then I'm moving it up. So make sure it works when you apply these. Okay. Define the domain and range. The range is all real numbers. So the range is going to be all real numbers, but the domain is going to be everything from 2 to infinity, right? That's where the vertical asymptote is. So g of x approaches to negative infinity as x goes to infinity, and g approaches to infinity as x goes to 2. Okay. If we reflect this with the y-axis and find the equation, this would be g of x equals negative log base 2, and then just negative x minus 2 plus 3. So reflecting over y-axis just means make the inside x negative. Okay. Find the domain of the equation log x squared minus 1. So remember that what is not in the domain of logs? Well, log cannot be 0, and log cannot be negative, right? So basically, we want to find out when x squared minus 1 is greater than 0. That's the only place that this is going to work. So that means that if I solve this, so we can set this equal to 0, x squared minus 1 equals 0, x squared equals 1, x equals plus minus 1. What this means is we are intersecting, our parabola is intersecting here at negative 1 and 1. So it's negative or 0 from everywhere from negative 1 to 1. So that means the domain would have to be everything from negative infinity to negative 1 and everything from 1 to infinity. So what I do here, I just found out where this was 0 and negative, and then I excluded that. So I looked at this as a separate problem. I wanted to find when that was greater than 0. And then I found out where it hit the x-axis, drew a little picture. Like, okay, well, it hits, this is where it's hitting the x-axis. Therefore, this is going to be excluded from the domain because this is negative or 0. Okay. Expand the following using laws of logarithms. So we have multiplication at the top and then some division. So we're going to have log x plus log y to the third minus log z squared. Then using the law 3, we're going to bring out those coefficients out front. So we're going to have log x plus 3 log y minus 2 log 2. Okay. For b, we're going to start by rewriting this as x over y to the 1/2. Then using rule 3, we're going to bring that out front. So we're going to get 1/2 ln x over y. And then we're going to subtract. So we're going to have 1/2 parentheses ln x minus ln y. That is the expansion of b. Okay. Let's condense the following using the laws of logarithms. So when we subtract, that is the same as division, right? So this is the same as ln x squared minus 25 over x plus 5. Notice that x squared minus 25 is a difference of squares. So I can rewrite this as ln x plus 5 x minus 5 over x plus 5. Then these would cancel. And so my answer would be ln x minus 5. Okay. Last one, B. So this one looks a little more complicated. We need to, before we start combining, we need to get these coefficients out in front of the, or on, as an exponent. We need to rewrite the coefficients as an exponent. So we're going to have log base 2, 3 minus log base 2 x to the third plus log base 2 x plus 1 to the 1/2. Okay. Then we are going to apply our rules. So we're going to have, I'm going to do one step at a time. We're going to have log base 2 3 over x to the third plus log base 2 x plus 1 to the 1/2. And then we're going to have log base 2, and I'll multiply that, so it's going to be 3x plus 1 to the 1/2 over x to the third. That's it. Okay, we got some equations. Solve the following. Okay, so this is a gimme. This is the kind of problem where you want it. You want the bases the same on both sides, log base the same, and then you can set the insides equal to each other. So this is going to be x squared minus 2x equals 5x minus 12. Set equals 0. We're going to get x squared minus 7x plus 12 equals 0. Then x minus 3 and x minus 4. And then so x equals 3 and x equals 4. And so you want to make sure, okay, when I plug these in, do I always get positive values? No 0, no negatives? Yes, I do. So these are good. Okay. No extraneous. Here, very similar to A, except we need to combine these two first. So we're going to have ln x times x plus 3 equals ln 20 minus 5x. And then we can set these equal to each other. So we're going to get x squared plus 3x equals 20 minus 5x. X squared plus 8x minus 20 equals 0. Factors are going to be 10 and negative 2. X plus 10, x minus 2. So x equals negative 10 and x equals 2. So here, negative 10 is not going to work, right? When I plug it in, it's extraneous. So we don't include this one. X equals 2 is our answer. Okay, so make sure you check either one back into the equation. Make sure you don't get 0 or negative. Okay, here this is the type 2 where we're not going to get logs the same on both sides. We're going to have logs on one side, and then we're going to have a number on the other. So here we'll get log negative x times 6 minus x equals 2. We're going to multiply these. So we're going to get x squared minus 6x log base 4 equals 2. Then we're going to rewrite it as an exponential. So we're going to say 16 or 4 squared, that's 16 equals x squared minus 6x. Therefore, 0 equals x squared minus 6x minus 16. Factors are going to be x minus 8 and x plus 2. So solutions would be x equals 8 and x equals negative 2. So what works, what doesn't? Well, when I plug it back in, the 8 is actually not going to work. It's going to get me negative value here, negative value here. That's extraneous, but the negative 2 will work just fine. So that's my solution. The other one's extraneous. Okay, so two types. One is get the logs the same on both sides and then set them equal to each other. Type 2, you got logs on one side, you got a number on the other, and you isolate the log and then rewrite it as a exponential. Okay, D, we got an exponential. This one, there's no rewriting the bases. We're going to get the exponential low, plus 3 both sides. E is 7 plus 2x equals 3. We're going to rewrite this as a natural log. ln of 3 equals 7 plus 2x. Just going to get the x alone at this point. So we have ln 3 minus 7 equals 2x, and then ln 3 minus 7 over 2 equals x. Done. That's it. You don't need to do any more there. You're done. Okay. Let's see what we're doing here. All right. This is another exponential. So this is the other type of exponential where the bases can be set to the same, and so we want to do that. So 1 over 25 is the same as 5 to the negative second to the power of 2x plus 1. And then we have 5 to the third to the power of 3x minus 2. We're going to multiply the exponents here, so we're going to get 5 to the negative 4x minus 2 equals 5 to the 9x minus 6, and then we're going to set those exponents equal to each other. So negative 4x minus 2 equals 9x minus 6. Let's get x alone, so we're going to get 13x equals 4. So x equals 4 over 13. Okay? You don't have to check for domain for exponentials because everything is in the domain for exponentials. Okay? All right, next one, we're back to another log. So this one, again, you cannot, it's not logs on both sides. We've got log. Oh, no, we could move this one over, and then we could set the insides equal to each other. You have a choice here. You could move this one over, and we could set the insides equal to each other, or we could rewrite it as a log. So either way is fine. I'm just going to rewrite it as a log. So we're going to have here log base 7 9x equals log base 7 49. Sorry, did I say equals? Minus equals 0. So then log base 7 9x over 49 equals 0. We can rewrite this as log now. So 7 to the 0 equals this. So that means that 1 equals 9x over 49. Therefore, 49 equals 9x. Therefore, x equals 49 over 9. Okay? All right, next one, same idea. Going to combine them. So we're going to have log 4 base 4 2x plus log base 4 7 to the third equals 3. Then log 2x times 7 to the third equals 3. Then we'll have 4 to the third equals 2x times 7 to the third. And so then we will divide both sides by 2 times 7 to the third, 2 times 7 to the third. So our answer is x equals 4 to the third over 2 times 7 to the third. Okay? There we go. All right. Last equation. So this one is a quadratic style where it's the same idea, but you have an extra step. 3, we're going to rewrite this as an exponential, so it's going to be 3 squared equals x squared plus 7x minus 9. That's 9 equals x squared plus 7x minus 9. So that means that 0 equals x squared plus 7x minus 18. Factors of that will be negative 9 and 2. No, sorry, 9 and negative 2. So x plus 9x minus 2. So x equals negative 9 and x equals 2. Let's make sure they work. Yes, that will be fine. And then the 2 is also fine. So both work. Okay? So again, I'm checking for negative or 0. And neither of them will get me negative or 0. All right, now we got some word problems. Suppose that $12,000 is invested in a savings account paying 5.6% interest a year. Write a formula for the amount in the account after 2 years if it's compounded monthly. So this is just like the formula. You just have to know the formula. So again, the formula is A of t equals the principal, 12,000, times 1 plus r, 0.056 over n, 12, to the power of 12t. Done. Find the amount after 3 years that was compounded daily. So we're going to say A of 3 equals 12,000. 1 plus 0.056 over 365 to the power of 365 times 3. That's it. You leave it just like that. That's fine. How long will it take for the amount in the account to grow to 20,000 if it's compounded continuously? So we're going to say 20,000 equals some we know the p, 12, we're just solving for time. 12,000 p pert, p e to the r 0.056, and we're solving for t, time. So this means that we'll have 20,000 over 12,000 equals e to the 0.056 t. We're going to take the natural log of both sides, so we're going to get ln, I'll figure out what that is, 20,000 divided by 12,000, that's 1 1/3. So I'm going to simplify that, that's just 5/3. 5/3 point equals 0.056 t. So last step up here would just be dividing by 0.056 both sides. So the answer would be ln 5/3 over 0.056 equals t. That is your answer. Okay. All right. Now we got the applications. 7, half-life Krypton 91 is 10 seconds. At time t equals 0, a heavy canister of 3 grams of this contains 3 grams of this radioactive gas. Find a function m of t equals m naught 2 to the negative t over h that models the amount of Krypton 91 after t seconds. So we have m of t equals the starting amount, which is 3 grams, times 2 to the negative t, we don't know t, divided by 10 seconds. Okay. One thing important is that the units of these need to be the same. The units of t and the units of h need to be the same. Okay, so for b, to convert it into this form, we need a point from the original. So we're going to say, you can choose any point you want, but 10 is nice just because it's going to put a 10 in there. So m of 10 equals 3 times 2 to the negative 10 over 10, which is that's just negative 1. So this just equals 3 over 2. Then we're going to say that 3 over 2 equals 3e to the negative r times 10. So I'm plugging in that y value and x value into this. So what's my y, that's my x, my output and my input. Then we're going to solve for r. So we're going to divide both sides by 3. So we're going to get 1/2 equals e to the negative r times 10. And then we're going to have ln 1/2 equals negative r times 10. And then ln 1/2, and then divide both sides by negative 10 rather. And that would get us our r. So our r equals, put it up here, r equals ln 1/2 over negative 10. Then when I plug this in into my equation, it's going to be m of t equals 3e to the r, which is ln 1/2 over negative 10, negative ln 1/2 over negative 10 times t. So that's it being rewritten. How much Krypton 91 remains after 1 minute? So 1 minute equals 60 seconds. We have to make sure that matches. So we can use either of these formulas. This first one would get us m of 60 equals 3 times 2 to the negative 60 over 10. And that's your answer. That's it. Okay. Remember that this is giving you the time. Like this is writing it in terms of having time. So it's like this is how long it takes to have. Whereas this is giving the relative growth rate. So this is giving you, oh, it's decreasing by this percentage every time. Okay. D, after how long will the krypton be reduced to 1 microgram? So similar, we're going to just rewrite this out, 0.00001, 1, 2, 3, 4, 5, yes, equals 3 times 2 to the negative t over 10, and then I'm solving for t. So this would be 0.000001 over 3 equals 2 to the negative t over 10. log both sides, you're going to get log base 2 of 0.00001/3 equals negative t over 10. Multiply both sides by negative 10. We get negative 10 times log base 2 0.00001/3 equals t. That's it. Okay? The initial size of a culture bacteria is 1,000. After 1 hour, the count is 8,000. Find a function n naught e to the rt that models the function after t hours. Okay. So we have a point. We know that n of 1 equals 8,000. That's all we need. N of 1 equals 8,000. Then we can plug that into here. So we're going to say that 8,000 equals, my starting amount is 1,000, e to the r times 1. Got it? Now we're just going to solve for r. So that would be 8,000 divided by 1,000 is 8. 8 equals e to the r, which means that r equals ln 8. Okay, so rewritten in this way, it's going to be n of t equals my starting value 1,000 times e to the ln 8 times t. Find the population for 1.5 hours. Really simple, which is n of 1.5 equals 1,000 e to the ln 8 e to the ln 8 times 1.5. Okay, that's it. After how many hours will the number of bacteria reach 15,000? It's the same idea, just in reverse. 15,000 equals 1,000 e to the ln 8 times t. So we're gonna have 15 equals e to the ln 8t. So that's natural log of 15 equals ln 8t. So ln 15 over ln 8 equals t. Okay, final problem. A roast turkey is taken from the oven when its temperature is 185 degrees Fahrenheit and is placed on its table, room temperature of 75 degrees. So I would give you the formula. The formula's not here, but I would give you the formula. The formula is T of t equals Ts plus D naught e to the negative kt. Okay, and this Ts, very importantly, is the ambient temperature. So Ts is the ambient temperature. D naught is the difference between the substance temperature and the surrounding temperature. K is a constant for this particular turkey, and T is time. Okay, so let's do a practice problem. If the temperature of the turkey is 150 degrees after half an hour, what is the temperature after 45 minutes? So let's write it out. We know that after half an hour, so that's 30 minutes. Let's write it in minutes, because that's in minutes. So T of 30 equals my ambient temperature is 75. This is my Ts. And then the starting temperature of the substance was 185. So 185 minus 75 is my D naught, which is 110. So plus 110 e to the negative k times 30. Okay. So we would need to solve this for k. So to solve this for k, we are going to get, also this T of 30 is just 150. This is just 150. So 150 minus 75 is 75. So we're going to have 75 equals 110 e to the negative k times 30. So we have 75 over 110 equals e to the negative k 30. ln both sides. Ln 75 over 110 equals negative k times 30. Divide both sides by negative 30, negative 30. This is my k. Okay, I'm gonna need more paper. Okay, so now I can rewrite my equation out from scratch. So it would be T of t equals 75 plus 110 e to the negative ln 75 over 110 over negative 30. Ln 75 over 110 over negative 30 times t. So after 45 minutes, this is still a. After 45 minutes, all you have to do is plug in a 45. T of 45 equals 75 plus 110 e to the negative ln 75 over 110 over negative 30 times 45. It's that easy. Okay, you're done. You don't need to do anything else here. And then how many hours will it take to cool the turkey to 100 degrees Fahrenheit? So interesting, this is in hours. We need to pay attention to that. We can still keep it in minutes. We will convert it at the end. So we're going to keep it in minutes right now. So this would be 100 degrees. That means this output needs to be 100 degrees equals 75 plus 110 e to the negative ln 75 over 110 over negative 30 times some t. Okay, we're going to get t. We're going to get t alone. So it means 25 equals 110 e to the negative ln 75 over 110 over negative 30 t. Divide both sides by 110. Divide both sides by 110. So we're going to have 25 over 110 equals e to the negative ln 75 over 110 over negative 30 t. Take the natural log of both sides. Ln 25 over 110 equals negative ln 75 over 110 over, at this point I can make that positive now, t. And so my last step, divide both sides by this, we're going to get ln 25 over 110 over ln 75 over 110 over 30 equals t. Okay, I did this part in the calculator just to kind of put numbers to this, but this essentially equals, I would accept this in minutes. This is the correct number of minutes. So this is in the calculator 297.05 minutes. So to convert that to hours, we would multiply it by hour over 60 minutes. So we're basically dividing it by 60. So it is 4.95 hours. Okay. So again, you have no calculator, so you can leave it in exact form. I'll avoid making things too complicated and like a little bit too much, but you don't need a calculator. You can write it out in exact form. I don't expect you to evaluate it. But for just context, this is what it means in real numbers. That's it.